So we're going to have a look at tier 2 and 3 ISPs and service providers, kind of reaping the same benefits from open networking and network disaggregation as tier 1s and kind of hyperscale data centers have before them. So we're going to have a look a little about EPS. We'll have a look at market trends and the general open networking ecosystem. 3 use cases: disaggregated cell-site gateway, Cassini transponder, bare metal switches and aggregation routers, and then a few questions at the end if we have time. So EPS are 21 years old. We're an Irish company. And I suppose we got involved in open networking around 2013 when we became distributors for edge core networks. And from that, we got relationships with all the NOS vendors. And what we like to do, I suppose, is take some of the hassle out of open networking. So it can be a bit daunting. Say a company will say, right, I want a bit of software. So we'll say Pluribus. Now, what hardware does that work on? Now, what transceivers work with the hardware? So it can get a bit complicated. So we take that complication away for our customers and basically have switches with the NOS installed, the licensing, transceivers bundled in, ready to slide into racks. And we do that for our software vendor partners as well, actually, branding and so on and so forth. So we're 21 years old. We've 28 global locations, and we have 3 disti hubs, 1 in Dublin for EMEA, 1 in Shenzhen in China for Asia, and 1 in Indianapolis for the Americas. So we have the globe fairly well covered. Okay, so the open networking ecosystem. So I suppose you can look at it from 3 kind of organizations. So we have the ONF, the Open Networking Foundation, the OCP, which is the Open Compute Project, which looks after hardware and some software bits as well. And then we have the Telecom Infra Project. I'm going to speak about the ONF and TIP. So I'm not going to go into the history of open networking because we'll be here all day. So we started in 2016 and they started work on their platform called Cord. So Cord's a platform and then projects run inside it. So it's central office re-architected as a data center. And the idea was for telcos and carriers to kind of reap the same benefits that hyperscale data center guys did through using bare metal and open source software. So 2019, we had reference designs for some of the projects within the platform. And then late 2019 and 2020, we had production rollouts for some of the projects. So SIBA, AT&T, Deutsche Telekom, Turk Telecom, Trellis, which I'm going to mention in a little while, and a lot more. So it's been a success to this point. So just looking at a report from 650 Group on, I suppose, the addressable market for the next 5 years. And for these areas, they reckon it's 490 billion. So RAN, Evolved Packet Core, optical transport, service provider, router, and broadband access. I know the ONF particularly are looking to take a big chunk out of broadband access using their SIBA pods, maybe a bit out of optical transport with their ODTN project, and again, OMAC as well in their Evolved Packet Core project. And a little bit in Open RAN, but we'll see now when we look at TIP. TIP are going to take a good chunk out of Open RAN and the optical transport part. Okay, so the Telecom Infra project. So this started around the same time as the Cord project started in the ONF. And obviously they work closely with the ONF, so as not to overlap, I suppose, on projects. There is some overlap, but not too much. And they work with the OCP, so a lot of the hardware they use comes directly from, or was born in the OCP, as we like to say. They have 500 members, we're members ourselves. They've got a marketplace where you can look at the end-to-end solutions and the projects within those end-to-end solutions. And they've split their projects into 3 distinct categories. So we've access, so that's just basically the RAN access. So Open RAN, I'm sure everyone's hearing about this over the last couple of months. And we've transport, which is backhaul from the RAN back to the core. And then we've core and services. There's a few projects there on segmentation and slicing. And projects we're involved in between the 3 organizations. So we're heavily involved in a backhaul project called the Open Optical and Packet Transport. That's with TIP. We're working with TDF in France on ONF SIBA pod, working with Mundo Pacifico in Chile on a Cassini transponder installation. We're going to be looking at the Cassini now in a minute. And we've installed open networking testing labs in the UK. And we're also working on OCP server labs for network function virtualization infrastructure. We've been putting OCP hardware in data centers in the UK now for 6 or 7 years, but now we're starting to put the same hardware into tier 2 and 3 service providers. And we have a particular focus on bringing OCP hardware to Africa now as well. So we just started to add partners, but that's going to be a more 2 to 3 year project. Okay, so cell site gateway. There's a video going to run on the bottom left here, which is kind of explaining the open optical and packet transport project. But I'll batter on and talk away while you watch that. So, what is it? So it's well, at first it was created by Vodafone, Telefonica, TIM, Brazil, BT, and Orange. Basically created the design specification for what they wanted, and then in the who there you'll see Edge Core, UFI Space, and Delta. They went off and they built the actual hardware based on those specifications. And what we ended up with was a 1RU cell site router, supports layer 2 and layer 3 with MPLS, with time sync, and it's built for the existing 2, 3, 4G networks and new 5G mobile infrastructures. I'll play that video again, actually, in case you didn't see it. So why was it required? Well, mobile base stations connect to cell site gateways using SFP or RJ45, but now with the 405G networks, it's going to be 10G SFP and plus interfaces. So basically the cell sites that are out there, cell site routers, are not fit for purpose anymore. Who's involved? So on the hardware side, we've got hardware from EdgeCore, IP Infusions, Alknos, AT&T's Danos Viata, Exynos from Exaware, and Verb from Volta, and offering some Infinera and Altron as well. So how can you get your hands on it? Contact us. We can get you testing units as well, and trial licenses and all that kind of stuff, or go to the exchange at tip. I think it comes back to us anyway. So, and impact-wise, it's had a huge impact actually. So obviously you're going to get capex savings when you use bare metal or white box, but I think AT&T are in the process of deploying 60,000 of these boxes, which has really helped them reach that 75% virtualization goal. And there's big deployments going on globally. Telefonica, Telia in US, Germany, South Africa, Taiwan, lots more. This particular project, the OOPT, has been a massive success, and this particular product has been a huge success as well, as you can see by those numbers. So use cases. So there's two main use cases. So we've got Greenfield 4 and 5G, and we've got 5G site upgrades. And if we look at on the left, at the bottom, so our kind of classical or traditional RAN, a radio unit, distributed unit, and centralized unit, and the cell site after it. But we can do it multiple different ways. The placement can be different depending on mid-haul, front-haul, and backhaul. We've got some other use cases: customer edge router in dual home, IP MPLS ring, and then a provider edge router in backhaul networks as well. If you need to talk about any of these, please go to the booth after. Actually, you don't want to listen to me twice. I'll just mute that. So it's a video of me installing a DCO line card into a Cassini transponder. So you can watch that while I talk about it. So what is it? It's an open packet transponder. It's the first of its kind, and very importantly, it's modular. So it integrates 100 gig layer 2 and layer 3 with layer 1 optical transport. And that's implemented by the line cards you see there. So there's 8 line cards. We've eight line cards, and we've got 16 QSFP ports as well. Why? So I suppose when EdgeCore were building this, they did it in conjunction with the tier ones, and modularity was one of the big focuses. So they don't want to be going out replacing a box every 2 or 3 years when they move. So basically, once you move from 100 to 200 to 400, and this box is 400 gig ready, you're just going out and you're sliding a line card in. And as well, the modularity side of it helps for smaller guys as well. So you only have to fill one line card on one side and one on the other to get you going. And as the business takes off, you can populate the device. There's flexibility. So we've obviously 100 or 200 gig. We've ACO or DCO, and we've got 100 gig QSFP as well. So who was involved? So EdgeCore Networks, Lumentum on the optics side, Fujitsu, NTT, and then IP Infusions, Oknos on the software side. There is open source options, Sonic and Goldstone, but actually I don't think they're production ready at present. Excuse me. So if you want to get your hands on one, speak to ourselves at EPS, or again, go through the telecom infra projects, either marketplace or onto the project itself, the OOPT. So some use cases. So the first one there, DCI, data center interconnect. So obviously over 100 kilometers, under 100K, we have some nice solutions for smart optics. But over 100 kilometers. The second one on top, service provider backhaul. So this again is our OOPT project. So we have our cell site gateway into our aggregation routers, then into Cassini, then amplified depending on distance back to your core. We've Metro, and we've backbone transport use cases as well. Again, come to the booth and have a chat with me if you want to know more about the use cases. Okay, finally, to finish up, switches and aggregation routers. So if you see on the right-hand side there, the image is Spine and Leaf, which is traditional now in data centers, but there's a project within Cord called Trellis, which isn't an acronym for a nice change. I think it probably describes the kind of fabric, but basically it's Spine and Leaf within the central office. So we have a wide range of bare metal switches for that, 1 to 400 gig. We have 10 and 100 gig edge routers using the Broadcom Strata DNX chipset, so the Qumran AX, MX, the Jericho 2, and those routers support time sync, have big buffers, 8 gig buffers, and external TCAM for quick lookups. Again, we have relationships with all the software vendors in this area, and that's one of the things that we pride ourselves on. Bare metal servers, so Lanner and or Super Micro, I should say, for the bare metal servers, and then OCP servers from Quanta, which we're seeing a huge uptake on recently. Then traditional layer 2 plus managed switches. We've got open line systems from Smart Optics, industrial PoE switches, we're global disties for Finisar optics, Amphenol cables, and CTC Union. So all the accessories that you might need for your network. And very quickly, we have a dedicated service provider solutions page. So we'll have all the hardware, all our software partners, traditional hardware and accessories, and then links to webinars we've conducted with our software vendor partners on specific topics for our service providers in open networking. And I've written a heap of blogs there on end-to-end solutions and individual products. So thanks for listening, guys. That's me.
Cool. Thanks, Barry. And as you can be in the booth later to chat through in more detail. You mentioned you mentioned software vendors within that. Can you explain a bit more about some of those particular vendors?
Yeah. So I suppose the software is going the same way the open networking data center software went. So when that started, you kind of had the big hyperscalers building their own software. So FBOSS from Facebook, Sonic from Microsoft, but then all these other guys started appearing. So you had Pika 8, Cumulus, Pluribus, so on and so forth. But basically they had their own little niche area, and that's what we're seeing now. So when I look at the cell site gateway, for example, so we've got ADVA, then we've got Exaware, and Exaware that comes from a big powerful routing stack. We've got IPI's Oknos, which comes from the data center side, moving back out. We've got Volta Networks, which you can split the router into 254 virtual routers. So it's going to be brilliant for multi-tenancy. So they all have their own little areas, and that's where kind of we come in, is to help and advise, get trial license and all that kind of stuff for our customers.
Cool, thank you. I think we're conscious of time, so thanks again, and hope to see you at a future ISPA event or two as well.
Yeah, love it.
One day, who knows?
Cool. Thanks, Andrew.
Thanks, Barry.